This is 5.6, number 75. So these questions, a lot of times they're rooted at misconceptions, misunderstandings that are often made. So what is going on with A? So A, if you look, it's actually a pretty quick U sub, because if I'll show you what's happening. If U is f of x, du is f prime of x dx, right? You just take the derivative of that. Well, if you look, f prime of x dx, that's du, and this is u, and the antiderivative of u is u squared over 2. Well, this is u squared over 2. So that one is correct, doing a straight, quick u sub. The next one, it's a very similar thing. It's another u sub. The function inside of another function, I always tell you, is a good candidate for u. So if you make that u, du would be f prime of x dx. Look, f prime of x dx is du. Okay, so you have, what you end up with is u to the n du, and use a power rule. What's the power rule? You add 1 to the exponent, so it becomes n plus 1, and you divide by that n plus 1. And so that one also is a pretty straightforward u sub. Just looks different because instead of having the actual function, they just give you f of x. So you can just treat the f of x as your function and just do your normal u sub on those. So part C, this is a u sub again, and 2x inside of the sine function. And so 9 times out of 10, the function inside of another function is your best candidate for u. So u would be 2x, du would be 2 dx. And here's the question, and I'll do this a second way for you guys. Do I have 2 dx? I'll do that in gold. Golden. Do I have a 2 dx here? And the answer is no, and I need 2 dx because I need a du. I don't want dx, I want to convert this to a du, and so I need a 2 dx to be able to change that. So how can I get a 2 there? I learned that 2 divided by 2 is 1, and I learned in first grade, if I multiply by 1, not first grade, third grade, if I multiply by 1, it stays the same. So I put a 2 here and a 1/2 here, and I didn't change anything because 2 times 1/2 is just 1. Now this becomes 1/2 integral sine u du. So this became du, and that's sine u. And so now I've rewritten this with a new variable, and everything is u's. And if I gave this to you before we got to chapter or 5.6, you'd say, I can do that. I know the answer to that. The antiderivative sine u, I think, is cosine u, right? And you double check. You say, what's the derivative of cosine? You say, oh, it's minus sine, minus. So therefore, I need a minus. And then you replace u because your original equation was with x's. So I got to go back to the x here. It's going to be cosine, and u is 2x. So that's the proper answer. So this is definitely false. All right, letter D. Ooh, I see the problem with D. This is inside of the x to the 9th function. So I want to replace that with u, because it usually works when I pick that for my u. So u is x squared plus 1. I need the derivative of that. So du dx is 2x. But I'm going to multiply both sides by dx. So I get 2x dx. And here is the problema. Do I have 2x dx right here? And the answer is no. If I was missing a 2, I could do the 2 and 1/2 trick, but I can't get an x in there. Someone might say, can't I just multiply by an x? And someone might say, okay, I have the answer. I'm going to multiply by 2x, and then I'm going to put a 1 over 2x in front, and you can't do that because you can't pull variables out, only constants. So if you did that, you're stuck with an x inside here and you're in trouble again. So that's not going to work. So in this case, there's no way I'm going to get the 2x dx because I'm missing the variable x. And because I can't do that, I can't use sub this, and therefore I can't do this problem. So D is false. You can't just add 1 to the exponent and divide by that because I don't have the du here. And the last one, ooh, interesting. Very interesting. So if I were doing this, I think I said, you know what, let u be f prime of x dx. That looks good. And then the derivative of that would be the second derivative of x. Whoa, where'd that dx come from? I don't know where that came from. So du dx would be that. And I multiply both sides by dx. And I have something like that. And then I said, okay, I got this. I got this because look, second, that is that. So that's du. And this is u. So I have the integral. Oh, I know exactly what they're getting at here. This will be u du. Now, I already have a mistake. Here's my mistake, my first mistake. See that dx? Ooh, let me change the color. See that dx? That's telling you these are x's. A and b are x's. So let me label that x is a, x is b. Those are the variables you're starting and ending for your net area. You're going from a to b. But when you change everything to u, you can't put x's here. You need to tell me the starting u and the ending u. You need to change these to u. So let me get rid of those. You need to make that a u equals and a u equals. So there's a lot of problems in this problem, as we're going to see. So if x is a, if I plug a here, what's u? It's f prime a. This should be f prime of a. And if I plug in b here, what's u? It's going to be f prime of b. This is getting very strange, this problem. Okay, now let's find the antiderivative. That's going to be u squared over 2 from f prime of a to f prime of b. Using the fundamental theorem, you would plug in f prime of b first. Then you would plug in f prime of a and subtract them. Wow. This looks nothing like that, not even close. So that's a no bueno problema. Okay, so that is letter E. And I lied to you. I told you I would show you another way to do something. So on part C, I'm going to show you the other way. This is the bonus edition. Remember on DVDs at the end, there's bonus material. Here's your bonus material. You might want to take this recording and show your friends the bonus material. Look, there's bonus material on this problem. Okay. So as I look at this problem, I notice poopers. I don't have 2dx here. I need a 2 there, but I don't have it. So the other method is to solve for dx. I'm going to divide both sides by 2, and I get dx is du over 2. I'm going to take this du over 2 and plug it in for dx. Okay, that's my substitution because I want the du to turn into it. I mean the dx to turn into a du, so I can substitute that in. What will I get? The 2x becomes a u, so I get sine u, and the dx becomes du over 2. Now that 2 is a constant, I can pull it out in front. And then you go through the same process I just went through previously. So that's the other way. It's just another technique of replacing all the x's with u's. Some of you like that better, and some people like the other method where you kind of manipulate to make a match. But that's the bonus for that problem.